Hey there, and welcome to another channel video where today from FNIRSI, the brand new 2C53P 3-in-1 device that features an oscilloscope with 2 channels and 50 MHz of analog bandwidth support, 10 MHz function generator, a 20,000 counts multimeter. Once again, FNIRSI filled a gap in the market where we have the very small and cheap oscilloscopes with displays up to 2.8 inches in 3-in-1 devices, where we can find the Zoe ZT703S or the ZT702S with a smaller display, the FNIRSI 2C53T or the DPO X180H 2-top ET829, and others where we can find a display from 2.8 to 3.5, and there is a jump to the biggest screens in portable mode, like the FNIRSI 1003D, or for a more high-end Mixig STO 1004, among others. So what is the gap? This scope meter has a display of 4.3 inches, positioning it in the middle of those devices mentioned previously. I'm doing this introduction after I have already tested it, and I will tell you if they were successful in the task of creating a small and portable device, but with the functionalities of a full-feature oscilloscope, function generator and multimeter. So bear with me. A quick pause for letting you know, as a disclaimer, that this device was sent for this review free of charge for me. FNIRSI didn't pay me to produce this video, and they will see it only after being published on YouTube. That said, let me thank them for their continuous collaboration with the channel by sending these devices for reviews, but let me send a big kudos to you, my viewer, that also sponsored the channel by using the affiliate access links on the screen or in the video description before doing your purchases on AliExpress or Amazon. You pay the same, but will become a channel sponsor just by using these links, so a big thank you. Without further ado, let me show you the key features. Okay, as always, let's see what comes in the box and what is delivered. The box is this retail box from FNIRSI, this good looking box. We can see immediately this is a 50 MHz oscilloscope with 2 channels, okay, 4-bit half-through RMS, intelligent and anti-burning, yeah, and a touch display. We have some specs here in the back also. A signal generator also included, and it is also a multimeter. So I expect to have also in here test leads and a probe. Let's start by opening. Okay, so what do we have in here? The normal FNIRSI quality assurance stamp. So we have a user manual. The user manual is in Chinese, English, and Russian and Portuguese. Anything else? No. So, like the latest FNIRSI manuals, it's very well organized, color images, infographics, and all you need to start working with it. So again, nice work. Whoa. This is bigger than I was expecting. Yeah, let's put it here. So let's see what we have below this styrofoam. We have a set of probes. This is the 16100 100 MHz probes, not test leads, and the set of test leads. This seem okay. And what else? Okay. For the function generator or signal generator, we have also this MCX adapter to crocodile or alligator clips. Okay, very nice. And still I was missing this, the charging cable, USB type A to type C. So yeah, let's put this and take this out of the way. Okay, so let's open this bag and see how it is, the 2C53. Yeah. Oh, very nice. Okay. It seems, I think I have one of the first units to get to the market. It's a little bit scratched, so it has some work in it. We have rubber in the corners. It will not slide while working it. Also the normal stand, as you can see in here. Let's see the position in this table. Yeah, it seems good. On the top we have two channels. Channel 1 and channel 2, I believe. No, I had to get my channel. Yeah, two channels, channel 1 and channel 2, and the function generator outputs. On the right side, we have the red connector for voltage, resistance, capacitance, and let me check, and temperature. Okay, this is the common milliamps and amps. So the common sockets in a multimeter, nothing on the bottom, and we have a button on off and USB connector, and also a reset button. This time they were more carefully, it's correctly signed. You have here the inscription. Let me put on the front camera. Yeah, like this, you can see reset button, USB for charging and update, and probably to take the image out of this, and the on-off button. This seems like a mic, but yeah, it's a button. Okay, it seems interesting. We don't have any kind of buttons to work with because this is a touch screen. Let me power this up. Very nice. The first thing that we have in here is the language selector. I will go with English. And then, whoa, what is this? Menu. Whoa, very responsive. Too responsive almost. Yeah. It's really just a little touch to select everything. Okay. Signal source, oscilloscope, multimeter, and settings. Okay, so let's start and see what we have in here. Oh wait, I was complaining about the scratches on the screen, but no, we can get the film out, so let's do that. Whoa, always like this part. Okay, now we got it. Totally new. Yeah, very nice. Now is the time to talk about this video sponsor, PCBWay. I always use PCBWay for creating my boards with a professional factory quality, as you saw in my millivolt voltage reference board. It is very cheap to manufacture your PCBs on PCBWay. You can manufacture 10 PCBs for only $5. How awesome is this? And it is pretty easy also. Just insert here the PCB dimensions and you'll have an instant code. So when you want a PCB, visit PCBWay to get your code, and if it is your first time ordering from PCBWay, you can use our access link for a $5 credit. And don't forget, they also have component assembly service, 3D printing service, and much more. So let's power this up again, and I will start by showing the setup, the settings of the device. For that, let's move, this one. In the settings, you have several languages, 8. Also, you can set the brightness by dragging this bar here, and also the sound. You can have a really loud sound or remove it completely. Okay, I will leave this in a very, like the first one. Also, you can change for blue theme or yellow theme. I will leave in the yellow theme, and maybe I will take out some of the brightness so you can see the highlights better. And yeah, then you have the startup on boot. You can set up for multimeter, oscilloscope, or signal generator, or none, and you will have that menu that we are looking at when I started. So you have also the auto shutdown. For that you have off, 15 minutes, 30 minutes, and 1 hour. Those are the options. You can activate the USB sharing in here, and with that you will be able to see on the PC a new drive. Let me see how we go back. Yeah. Okay, you press on off in the screen. And finally you have the about. That's the info of the version and the model. And also the factory reset. The factory reset, it's pretty fast to do. Okay, that's it in terms of settings. The menu I've shown you already. You just navigate through these options, and then we have those options in the end that we will see ahead also on the video while working with it. Basically that's it. Now we will talk about the oscilloscope. Before that I found out we can drag the options like this, but I figured out that it works much better if you just press in here on the left side or on the right side. It works much better. So let's take it to oscilloscope, select the option. I already have my function generating outputting a sine wave of 1 kilohertz. Let's do an auto. Okay, it takes yeah, it's not too long to do that. We have here on the screen the channel 1 information, the channel 2 information, and here we have the buffer or the record length and the position in it, and the trigger, and this is also a menu I will show you. And this sine wave here in the corner is the signal output of the function generator or signal generator, whatever you prefer. We have this circle here. Now it's with the pause button. If you press it, it will stop. It's the stop function. Also the trigger will show there. And the battery indicator. You have here the trigger indicator is this small yellow arrow, and also in the left side you have this light blue arrow and the dark blue arrow. So, and those are the indication of the middle of the displayed waveform. You can also drag it like this, and yeah, you will be able to move it. It's quite responsive. And for changing the time division, also you press left to increase and right to take it to the minimum, that is 10 nanoseconds. Okay, and you can see in here that the sample that is recorded on the buffer is very little right now. If you increase the time division, yeah, the sample will be bigger until it fills the record length. Okay, that's it. We have those options in the end, as I shown before. Okay, you have the stop run, also the auto, as I showed you already. Okay, and the menus on the top are, well, for channel 1 you have the on-off option. Also, you can change the amplitude, and for selecting the amplitude you select first the vertical indicator and you change by rotating. Let me show you. By rotating these options here on the right of the menu. Okay, so that's how you change the voltage of the vertical division. Like right now it's 500 millivolts, and let's put it again in 1 volt. Also the probe indicator you change it here. You have 10 to 1 and also 1 to 1. So 10 times 1 time. We don't have 100 times. Okay. Also, you have the coupling, AC, DC, the two options available. I will leave it in DC. And you can apply the 20 megahertz limit, bandwidth limit, also for each channel. On the, let me take it out. On the second channel, that's the same. Okay. And that's it. So we have also the trigger menu. And for the trigger mode, we have the auto, the currently trigger mode, the single, and the normal. That's the first one. And like previously, for the edge, you have the selector on your right. You have the rising edge, falling edge, and both. And finally, the trigger channel that it's currently on channel 2. Let's move it to channel 1. Okay, and that's it. Pretty easy to work, very, very intuitive. Let's see what else do we have in here. So we have in the bottom this function option, and for that we have measures. We can activate the measures like channel, frequency, and I want also, oops, VPP, yeah, VPP. And I think for this it will do. You can also save the waveform in the screen or the image, but it's not working. I don't know why. I have to see. We have also cursors, calculation, that this is math functions, and also FFT. Okay. We have the persistence with 1 second or infinite. And what else? We have also XY mode, correction, image, 50%, and course. So with 50% you adjust, let me take it again, with 50% you adjust immediately the trigger level and also the signal position. Okay, let me just try to, I will show you also this next one. You have the coarse and the micro. If you use micro, it will go very smoothly in the screen. Okay, it will be very slow to change the positions. Right now I'm with the persistence active, that's why you saw that in the signal. Let me take it out. Yeah, and if you use the curse, let me put in curse. I will do a 50% also to put it centered, and with course it's much faster to position everything in the screen. Okay, so that's what those buttons are for. Okay, we have math functions. I don't know, correction. Okay, correction is the calibration, and image image viewer, but I'm not being able to save image. I don't know why. Maybe it's something in the BIOS. Okay, I will test all these functions individually more ahead. Right now, what I will do is a bandwidth test. Okay, for the bandwidth test, you should have also in the screen my function generator, the SDG2100 from Owen. And we have already in the screen a sine wave with 1 kilohertz. As you can see here on the bottom, we have a frequency correctly detected. Also, it detects 1.03 volts, and for me this is very good. Let me change only, we are with the falling edge. I prefer the rising edge, yeah. Okay, so let's start by taking this to 100 kilohertz. Okay, auto. It detects 100 kilohertz with 1 volt, no issue there. Also the sine wave seems good. A little jump here. Yeah, it's jumping a bit, but yeah, seems okay. Okay, so let's move to 1 megahertz already. The maximum bandwidth of this device is 50 megahertz. I would expect to have something good until, well, 25-30 megahertz without any problem. Let's see. So 1 megahertz, we still have 1 volt VPP, so perfect. Also a nice drawn sine wave. We are now at ×1. The probe is also at ×1, and I will keep it up to 5 megahertz. That's what I will do now. 5 megahertz. Okay, auto. Okay, 5 megahertz. We have a drop, like 912 millivolts, still well within the 700 to 720 of the -3 dB, something around there. So we are good at 5 megahertz. So now I will change the ×1 to ×10 in the probe. Also here in the channel, where is it? This works surprisingly well, the selection. Okay, let's do auto again. So right now I am with the probe at 10 times. We had a huge drop. Yeah. Okay, let's take it to 10 megahertz. Auto. Okay, still within the -3 dB border. Let's take it to 25 megahertz. Okay, still good. Reaching really near the -3 dB, but we are still good. Okay, let's move it to 50 megahertz. This is the maximum. No one should use an oscilloscope at the maximum bandwidth, but yeah, now it's below 714, something around there. Yeah, it detects correctly. The sine wave is with some jitter. We are at 10 nanoseconds. It will not go any further, but it's usable. Yeah, the VPP, it's not quite the ideal. Let's bring it down manually to see what will be the limit. Okay, so right now we are at 725. Yeah, 725, 15. I will say that this will be very okay. Okay, let's try a bit more with auto corrected. Okay, again. Yeah, 40 megahertz. So yes, 37. Let's do 45. Yeah, 45 is already at 700. Yeah, like 42, something like there is the maximum bandwidth over the -3 dB. Yeah, this should be around for 32. Yeah, to be secure, 40 megahertz is the maximum above the -3 dB. Well, so in terms of bandwidth, I will finalize this with 41 megahertz as the maximum over the -3 dB. Okay, that's it. Let me now bring this back to 100 kilohertz and change this to a square wave. Let's do an auto. Okay, it looks good. 756. I am still in 10 times. I will change now to 1 time because I'm below 5 megahertz. Okay, do auto again. And yeah, right now we are 1 volt VPP. Yeah, and very good signal. Let's move directly to 1 megahertz to see the square wave, how it handles it. So it detects 1 megahertz. The VPP is still good. We have some, well, roundness in some corners already. So let's move this to 5 megahertz. Okay, I don't see this getting good. Okay, it's still up in terms of VPP over the 900, 720, but it detects the frequency very well. The signal itself, yeah. We have in here the triangle wave. Okay, and noise. I think that in terms of bandwidth, that's it. Let's move on to the other options. Taking advantage of the sine wave that I already have outputting from my signal generator, this 1 kilohertz sine wave, I will now show you how the cursors work. We can activate the horizontal or vertical cursors, or both. So you can see here on the left side the values from the deltas, and I think I will try with you to show you how this works. Let's first position the down line, now the up. It picks up very well. Okay, we are using coarse mode, don't forget about that. If we change to micro mode, probably will be more precise to position. Okay, let's do like this, and let's try to open the 10% to 90%. So all the values will be in here. I have to say that I have some difficulty to read this, so I will not say which values are on the screen, but everything is in here. Okay, so the cursors are really easy to use. You just put your finger on top of the line that you want to move and drag it. Really easy to use. Very nice feature. Okay, moving on. Now let's talk about the math functions. Before going on, I think that all this interference might be the adapter for my probe to connect directly to my function generator. I already tried to see if it's well connected, it seems, but the second one seems much better. Okay, so going back to the math functions, you have it here on the calculation menu, as they call it. So we start by, and if you used before the math functions, it's pretty easy. You just need to identify which function you want to use. For example, let's try channel 1 plus channel 2. And here you have it. You can also move this channel, I think. Or not? Yeah, I don't know. But you have the other functions, for example, multiply, divide, and subtract. Where is it? And subtract. Obviously tend to nullify itself. Okay, that's it. In terms of math functions, is basically what we have. We have -1, also -2, modulus, and modulus 2. Okay. Oops, let's go back. And in terms of math functions, that's it. We have also FFT, but I will talk about that one next. So we are in math functions. I will now show you the FFT. Okay. For the FFT, I will activate the sweep or modulation maybe. Let's see. No, modulation, it's better. Okay, and we have on the screen the FFT. I don't know if we can have FFT for both channels. We should, but is showing only for one of the channels, I believe. Let's go with noise. I will take now the channel 2 since it doesn't seem to have a FFT indicator on the screen. I will take it out, and also I will increase here, no, increase to the signal, so decrease the time range. Okay, you have how FFT will work on this device. It's a very simple graph, no special anything, no scale, no nothing, but it will give you an idea of the harmonics. Okay, this one is also covered. Let's move to the next one. Since we have the noise on the screen, let's do an auto. Okay, well, this will do. I will show you now the afterglow. So this is 1 second afterglow. Okay, and we can also have it infinite like this, and you can see there is some patterns on the signal that you can follow with this afterglow. In terms of afterglow, it's pretty simple to use, nothing here to show more. Back to 1 second, and let's take it out. Okay, now I will tell you about the XY modes. So we have two sine waves, 100 kHz each on the screen with a VPP of 1 volt. I will activate the XY mode. It's simple. Okay, it doesn't seem like it, but we have in here a circle. Let me bring this to the center. Okay, like this. They should be in the center, and I will start by animating this circle. Okay, for that you just change the value of the frequency and we have a very nice animation. Okay, very cool. I will even get the range of the amplitudes changed so it will be bigger. Okay, again, a very nice figure on the screen. We can even, let me just increase, for example, yeah, increase the spikes in here. Yeah, okay, it works really well. Let me try to do the same on channel 1. Yeah, and we have a totally different figure. Pretty easy to use, so renders quite well the signals and the lines, so I'm glad with it. Let's move on. For this part, I connected here on the DDS or function generator, signal generator, what you prefer, output the MCX plug or cable with the alligator clips connected to the probe of my of my oscilloscope that you have on the right side of the screen. So let's move to signal source and see what we have here. Okay, this seems very nice how this will work. Okay, I should be outputting a sine wave of 1 kHz. Let's do an auto in my function generator. Yeah, here we have it. The amplitude is at 3 volts, can be it can be reduced to 0.1 volt. Okay, also the duty cycle can be changed, not in this because it's a sine wave. Let's see on a square wave. Yeah, on a square wave we can change the duty cycle. You can see it on the screen changing. It's quite responsive. I really love this. And we can also insert the value with this keypad. So awesome way of working. So the frequency, I believe it can go up to 10 megahertz in yeah, like this, I believe. Okay, let me see. Maximum in sine wave. Well, this is a square wave, sorry. In sine wave, let's see again. Yeah, it's a 10 megahertz sine wave. The frequency says 10 megahertz. The VPP, it's really not the 3 volts. Let's put this at 1 megahertz. Okay. Not the best. It has some alias there. Okay, let's take it to what, 100 kilohertz. Yeah, it's aliasing there. Okay, this is giving a weird signal. Well, in square wave we are good. Sawtooth also, half wave. Let's see what else we have. Full wave, step wave, reverse step wave, and direct current. Okay, index up. So this is index down, multi-audio. Let me check if we can. Yeah, and this is the pulse, but I don't know if it is the cable or what the hell is going on here, but the signal is with a shadow. Yeah, analyzing. Okay, I went to grab this adapter from another oscilloscope, FNIRSI 1 I believe, to connect directly to the signal generator without using this weird cable. Let's see what else we have. We still have that shadow signal behind, but it's much better. Okay. We can stop the signal, start. If we go to 1 megahertz, it will be much more complicated. Yeah, we have that shadow below, behind, some aliasing there. Okay, but it seems to output what we need. We can go up to 5 megahertz, I believe, in these signals and 10 in the sine wave. Well, obviously the 5 megahertz, yeah, it's not the best, but it gives you 3 volts in the output anyway, and it detects the 5 megahertz. Okay, also with sawtooth, half wave. Yeah, in terms of the software, it's really easy to use, really easy to insert the values and to choose the sine wave. It's very intuitive. The problem that I'm seeing is mostly with the signal itself. Maybe it's something that FNIRSI can see and check better. We have a signal there, but it's always jumping with a shadow in the back. I don't know why. Maybe you guys can give me a hint. Okay, in terms of signal generator, that's it. Okay, now let's talk a bit about the multimeter. For the multimeter, they deliver those, or these Cat3 test leads, 1000 volts maximum, 20 amps. Yeah. CA, yeah. So this is not silicon, it's plastic, but they seem okay. They're quite pointy. Yeah. And with this L-shaped plug. Okay, let me connect this to the right place, like this. We have millivolts in this socket and amps in this one. Let's start with the multimeter. Okay, so what do we have in here? Let me bring my pointy stick. stick. So right now we are in auto. We have here the gear, run or stop, yeah, and it has the indication where to connect your test leads for what you are analyzing right now. What is this in the corner? Max, minimum, and yeah, we should be able to do something in here. Auto, function, gear. Okay, the gear is the menu. So let's see what we can do. Right now we are in auto, so it should detect anything that we throw at it. Let me try something like yeah. Let's see if he picks up. This is not yet the normal test with a resistance. Let's see. Okay. So this is a smart multimeter. Whoa. And let's go to capacitance. Well, in capacitance with picofarads it will not go there. Yeah, but with a higher, it seems with a higher capacitance might go there. I don't know. No, resistance, okay. Yeah, it detects with resistance. So capacitance, it's not on auto. Yeah, it's on auto with continuity. I will test later these functions like the continuity and everything else. So let's see what we have in here. So we have temperature. Okay. Always with that indicator in the background. It's detecting, I believe, 28 degrees, so it should be more around the 30, like in here. But okay, what else do we have in here? Okay, so we have amps, milliamps, capacitance, continuity, and diodes. Also resistance and voltage. Okay, and in terms of voltage, how do we change the DC? AC. Okay, nice. And this in the corner is a memory. We have also a graph in here. Hey, pretty cool. Pretty nice. Okay, and if I choose milliamps, for example, it will tell me immediately that I should connect my test leads in these two holes or sockets. Sorry. And amps should be in the bottom one. Yeah. Okay, nice detail, nice detail. And it's always on the screen. So even if you miss initially when it changes, it's always on the screen where it should be connected. I like very much this helper in here. Very nice detail. Okay, in terms of operation, we have this that will save the values in this, well, 5 slots. And you have also the history in here with the minimum and maximum. Stop to hold the values, and auto. Yeah, it will bring this to auto mode. Okay, that's it. Now let's test the different readings in the different modes that we have in here. So to start the tests, I will start with DC voltage measurement. As always, I'm using my Siglent SDM3045X on the bottom. We have the FNIRSI 2C53P on top, and here on the left we have my voltage calibrator. We'll start with the range of 10 volts, 9.99. So let's start first to see what is the voltage between 1 and 9 volts. Okay, 1 volt, spot on, very nice. 2 volts, 3 volts, 4 volts. Whoa, 5 volts. It has some difference in some of the digits, but don't forget that these have 4 digits, decimal digits, and that FNIRSI has only 3, so rounded, it's not such a big difference. Okay, 6 volts, 7 volts, even if we are with, well, 5 digits, 4 digits difference more or less, it's always the same difference. 8 volts, and finally 9 volts. Really good. Okay, so let's pass to millivolts range. We will start with 100 millivolts. Okay, should we change something or not? No. Okay, 100 millivolts, 200, 300, 400, 500, 600, 700, 800, and 900. It keeps to be spot on again. Okay, let's pass to millivolts, still millivolts, but 10 millivolts. Okay, 20, 30, 40, 50, 60 millivolts, 70, 80, 90, and again to 0. Now let's try with 1 millivolt. Yeah, 1 millivolt, it's not there yet. 2 millivolts, 1.9, 1.8, really near. 2.9 to 2.8, okay. 4 millivolts, that's the one we are here now. 4, 5, 6 millivolts, 7, 8, 9, and yeah, we're back to 0. And I don't believe, yeah, because of the scale, we will not be able to see microvolts. So 1 microvolt, yeah, we are pushing it. It will not go there. 8, 9. Well, 9, it's showing 7 microvolts, but yeah. Okay, back to 0. For most of the range, it's spot on, so I'm pretty happy with it. Let's move on. Now, while we still have the oscilloscope here on top of my multimeter, I will also measure the power line voltage. I will start by putting the neutral in, and now let me try. Okay. So what we have here, we have 238 volts on the Siglent and 237, 38, it changed on also on the FNIRSI. So spot on again. So I will move to the next test. Okay, I will start now by seeing the resistance measurement test. Okay, we have the normal board that I usually use for these tests. Let's start with 10 ohms. Okay, 10.28, not bad at all. We have, and in the board it's 10.00, so really near. Okay, next then we have 100.03 ohms. Let's try it. 100.81, very good. 1.0003 k ohms, kilo ohms. Whoa, not bad at all. 9.995 k. Okay, really near also. And finally we have 100.06K. Okay, this one, it will not go to 100. Let's double check it. We have 10 ohms again. 10.28. 100.06. Okay. 0.9998K. Okay, passes a bit the measure. 10.000K also, kilo ohms. Okay, not there also. And 99.971, I think. It's near. Okay, for measurement the ohms, I think that's it. Let's continue to capacitance. For capacitance, we will use the same board. We have in the first one 102 picofarads. Let me just change these to capacitance. Okay, so 102 picofarads. Far from it. Let's see this one, 99 picofarads. Also a bit far. So the second value is 1.02 nanofarads. Okay, 1 nanofarad in this one, and in this one it's 982 picofarads. Not far from it. The next one it's 10.4 nanofarads. 10.4, spot on. And 10.1 nanofarads. 10.1 also. Very good. The next one is 98.7 nanofarads. 99.8, okay. And this one is 100 nanofarads. Very well. Finally, we have 929 nanofarads. It should give 800 and something, like 877. Yeah. And also this will be better, but also it's 952, but it will give 926. So yeah. And finally, we have 10 microfarads. Okay, very nice. And 9.80 microfarads. Okay, this one passes a bit, but I think it's a good performance for the device. Let's see what else we have here. Okay, for diode measuring, let's start with this one. It should have a gain about 580, something like that. Yeah, it works okay. Let's turn it around to see. It shouldn't report anything. Okay, very nice. So in terms of LEDs, we have this one 1.7, a small one. You can see that it lights up. Also the second one, a bigger one, also 1.7 and also lights up. And 2.6 or 7, this one, a white, and it's not measuring. Well, it's not detecting this one. What is going on here? This one should be a 2.7 LEDs, and this not detecting. Weird. Okay, let me bring another device from FNIRSI. You know this one. Let me take the dust off. Yeah. And let's see what he detects in this one. Something like, oops, it's on reverse. Okay, it has light 2.6, like I told you. 2.6, 2.7, it's almost 2.7. Why is this one not detecting? Okay. Let me put this in auto mode. Well, in auto mode it will not even come close to work. Yeah, it lights up, but it's not able to detect the voltage of the LED. Okay, I will not spend any more time with this. Let's move on. Now it's the time where I will test the continuity of this device. And let's start. Whoa, a very loud beep. I hope that the mic captured this well, because it has a very loud beep. Okay, so let's see how fast it is. It seems pretty fast to update. And let's see how much time it takes to update the screen. Something about 2 seconds. 2 to 3 seconds to update the screen. Yeah. Okay, but it's very fast to beep. Ah, very nice. I like it. Okay, that's it for this test. For milliamps measurement, I have already my setup in place. I have on the right this FNIRSI SG004A outputting milliamps, and we will analyze that signal on the right with the FNIRSI 2C53P. Okay, let's start. 1 milliamp. Okay, pretty close. Let's take it to 5 milliamps. Very good. 10 milliamps. Okay, spot on. 15 milliamps. Very nice. 20 milliamps. Okay, 20.02, spot on also. And I believe the maximum is 24 milliamps, and really spot on every value. Yeah. Very nice, very nice. Okay, that's it. It was quick to test. Let's see what else we can do with this. Well, for temperature, this is the test where I feel less comfortable. I have this thermometer that I don't really trust much, but at least if I use this for body temperature measurement, it will give me, yeah, more or less the temperature that I believe that my body is on the outside. So it should go around 34, 35 degrees, something like that. Let me change to this side. 33, yeah, it's almost there. But one thing I am sure, that in this room it's not 32 degrees Celsius right now. So I don't know if this temperature is coming from a sensor or not. I have my body in the outside 34 degrees, so yeah, should be okay. I have 3 different probes in here, all of them from other devices, so but I am not sure if the sensor it will work in here. Right now I have this one here. Let's start to see how much it will measure. So one thing I'm sure, that my body is not at 40 degrees, so I will be almost delusional. Yeah, you may say that I am by doing these videos, but yeah, it's just for fun. Okay, so 40 degrees, no, it's not that. I have another one. Let's try again. Another probe, another sensor. Well, let's see what it says. 39 degrees. I believe that this should be calibrated. I don't know how we can calibrate the temperature. I don't see anything for that anywhere. So yeah, nothing much we can do there. And finally, I have this one that has this this probe. Let's see what we have in terms of temperature measurement. Well, it starts with 32 degrees, but no. I don't trust the temperature reading in this, so I don't know which chip it should use to do the temperature reading. No probe was delivered with the device, so yeah, but it's a feature that probably might be upgraded with a firmware upgrade. So let's wrap this up, and I have a lot to say, so bear with me in this conclusion. I will start with the price. You can find this scope meter on AliExpress FNIRSI official store for 102 euros or around $110 for my US friends. Since it created a category of its own in terms of format, the comparison is a bit harder, but if you analyze it by the functionalities, it's a difference of about 8 to 15 euros. Again, this is around $10 to $17 for the also 50 MHz dual channel Zoe ZT703S scope meter, or almost the same price for the Z-Way, the DSO 3D12. It's important to note that this last one has 120 MHz supported bandwidth and vocal commands. So in terms of price, in my humble opinion, it is in line with the market for what is offering to you. And what is that, you may ask? Talking about the design and construction, it looks good and it feels robust. That's simple. FNIRSI is creating a new category of cool to have devices, and this one is just one more step in the ladder. It's not just doing what you need in terms of testing, but looking good while it does. If you noticed, this is a trend on the biggest manufacturers too. Just take a look on the new black lines of devices from Keysight, Siglent, Rigel and even Handtech. But how about the features? Well, on a 100 euros device with so much in it, you can't expect to have everything perfect, and as you saw there is some flaws. The oscilloscope bandwidth was almost there, but still not a real 50 MHz at -3 dB oscilloscope. For me, 40 to 42 MHz is the bandwidth limit for this device. That said, while real 50 MHz is desirable, for me also this is not a showstopper, since it works really well up to that limit. On the function generator, the shadow or alias that is present on the output signal is a bummer and should be corrected as soon as possible. Finally, on the multimeter, I didn't have a great faith in the temperature reading function, but again, this should be easily fixed with a firmware upgrade. Now, the good part, the screen is really good and the touch works flawlessly. It is super responsive and it was one of the best touch oscilloscope experience that I ever had, including my awesome mixing. The UI is really good, very user-friendly. The only thing that was a bit over-engineered that was the scroll selector on some options. It is almost confusing sometimes, but everything else it is very well thought and easy to use. You are up to work in less than a minute. The oscilloscope, even if it's not going all the way up to 50 MHz, works pretty well and with nice results up to the 40 MHz. The multimeter, on the other hand, is really accurate, with spot-on readings in most of the tests, just having a small issue with the LED and that temperature calibration. The function generator UI is very good, very intuitive, and I loved it. It is also one of the scope meters with more bandwidth supported in the output. Just need to fix that shadow and it is perfect. So, as you can imagine by my comments, I'm really into this device. Even considering some issues mentioned before, all things summed, it was a nice experience. What do you think? Is worth buying? Let me know in the comments. But if you are thinking in buying one and you would like to support the channel, please don't forget to use the affiliate access links in the screen or in the video description before your purchases on AliExpress or Amazon. Same price to you, but a big help for the channel. A sincere thank you for your help. To sum up, if this video was useful to you in any way, please slap that like button to help me spread the word. And if you are new here and not subscribed, let me tell you that every week I receive cool electronic devices to review. So hit that subscribe button to be always on top of what is new in this market. That's it for today. Thank you so much for your company and I hope to see you in my next video. Until then, take care.